Hi, I'm Timo Harbo, and I run the course Python for Structural Engineers. In this video, I will show you how you can take the output from two finite element models and compare them with each other, so you can create visualizations like this one here that shows you the difference between the two models. In this case, it's a difference in pile reactions, but you can compare any metric you would want to compare. So a typical comparison of two finite element models that you will have to do on pretty much any project is a mesh sensitivity analysis. You don't want to have an overly fine mesh if you can avoid it, but you need to understand whether a finer mesh gives you significantly different results from a rougher mesh. So what we want to do is we want to take this model here with a rougher mesh. It's still not that rough, but we want to compare it with this one over here that has a much finer wall mesh. And for each of these models, we have outputted this results file. So you can see it's a huge file with a ton of different sheets in it. And in here, we have all the data that we want to compare. And you can see we have a folder here where in the first part of this module, we're going to compare this model with this model. These are both output Excel files with all the finite element analysis results. And then in the second part of the video, we're going to do a comparison of more models. But let's start by looking at these ones with the different meshes. So what we want to get to here is first the ability to make a simple reaction plot. We want to show the pile reactions under the building for each of these two models. So a plot like this here. So we can do that for both the models, but the really cool thing comes when we can combine them and actually compare them and create a plot like this one here, where you can see that this pile up here is 150 kilonewtons lower in the one model than the other, and this one here is 100 kilonewtons higher. So we can visualize the difference between the two models, not just side by side, but actually laid on top of each other. So let's go back up to the start and see how we can get to this here. So the first thing we want to do here is to import the libraries we will need. We will need pandas, we will need matplotlib, and we will need the OS module. And then we provide the two models that we want to compare. We want to compare the model 3 with updated springs, with the model 2 with updated springs with a fine mesh. And these here are both Excel files that contain all the output from our finite element model. Now this is done with ETABS, but you can get similar files out from most finite element software. The only difference is how you need to prepare it for the rest of the script. Then we can loop through the model names and read each of these Excel files into data frames. So if we run this code here, you can see that we now have this results data frame, which is a dictionary, and it has two keys. It has the model 3 and the model 2. So now if I go into my dictionary here and I say, I would like this model here and I want the joint reactions spreadsheet, I click here and I get the spreadsheet out. I can also get point object connectivity and I get that one out. So in this sheet here, I have the reaction in the piles, and that's the one I want to plot, but I don't have any location for where to plot this, but that I have over in this sheet here. Now, this first row here, we want to get rid of because there's no information that we need for the plot in here. So we go in here and we say drop the first row, and now that is done. And now we're ready to merge the data frames. So we loop through our dictionary, or in other words, we loop through our Excel files. And for the joint reactions sheet, we take out the columns we need, and we do the same thing for the point object connectivity. And from this one, we just need the X and Y value essentially. And then we're ready to merge them. So we put our joint reactions to the left side of the merge, point information to the right side of the merge, and we do a left merge, which means that if we have some point information about points that are not present in the joint reactions, well, then we shouldn't include them. We only want information about the joints that are in this sheet here. And then we have this little funny detail that in this sheet, unique name has a space between unique and name, and it doesn't in this sheet. So we can define left on as unique name with space and right on as unique name without space. We run this and we have now merged our data frames. So now we have all the information we need in a single data frame or single spreadsheet. We can show it down here and you can see we have X and Y values and we have the FZ value. Now to keep things a little bit simple, I only do this for one load case. You can of course loop through all load cases, but I just want to show it for the dead load. So we run this here and we have now filtered our data frame to only contain the dead load. And now we're ready to plot it. So we create a figure, we create a scatter plot, we place a point at each x and y location. We set the axis to equal to make sure that it's a geometrically accurate plot. And then we create a little tag above each point. So let's have a look at how that looks. So now we have just done this for one of the results. I could go up and change the path up here to the other one, and I would get a slightly different plot. So you can see we have the biggest reactions in these areas here, and out here we have slightly lower reactions. And also this color map we use here, Inferno, is really good at showing this in a quite intuitive way. So now we can do this for both our models, but what we actually want to do is to compare them with each other. So we need to do a little bit more work on our data frames. So what we want to do now is that we want to take our two data frames, the one we have for each model, and we want to merge them into one. So before we do that, we just do a filtering of both models. So we filter them for only the dead load case, and we only want to look at the value fz. So we do the filtering here, and then we get down to the merge. And this is where things get interesting. So we take our base model on the left side and our comparison model on the right side. And all the information we need from these now is just the unique name, so the name of each node. We need the x and y coordinates, but that is duplicate information. It's the same in both Excel sheets. So we just take it from one of them. And then we have the value parameter here, which is our fz value. And both data frames have a column named fz. So there's going to be a clash between the data frames here. But we solve that with suffixes. So we say that in the new data frame we now create, the one to the left, fz will get underscore base, and on the one to the right, it will get underscore comparison. And then we can merge them, and we get this data frame out here. This how is not so important in this situation, because I know I have the exact same piles in both models, so they will have the same structure. But now you can see the data frame we get out here. We have the name of the pile, we have x and y coordinates, we have the reaction for the base model and the reaction for the comparison model. Now we can create a new column, which we call delta, to be the difference between the two models. So we say it's comparison minus the base. You can see we now have the new column out here, which clearly is the difference between these two columns here. And now we can plot it. So we create a figure, we create the scatter plot, we set the axis to equal, and we put our annotations in. And you can see when we plot this here, we get this nice plot out here. And this here is an extremely intuitive way of seeing how the models perform against each other. But now we've just compared two models. What if we wanted to compare many more models with each other? So you can see in the folder here, we have these four models here as well. So we've gotten some values from our geotechnical engineer. And we of course want to use those in the project, but we also want to have an understanding of how sensitive our building actually is to changes in the stiffness values. Because these stiffnesses may change again and again and again. So that means that if we're able to get an indication of how sensitive the building is to a change in stiffness, we can react accordingly when we get updated spring values later on. So let's go back into our code here. So now what you will see here is a lot of repetition from what we just did, but just set up in a slightly nicer way and in a slightly more scalable way. So we provide our base model path. This is the model that we want to compare all other models against. And these are the four models that we want to compare. We only want to look at the dead load, and then we have some other control parameters here for the plots that I'm not going to go deeper into now. So we can run this here. Now the variables are declared. Then we have a function here that we've written to load the Excel file in the way we want to load it. So we declare that function. Then we load the base model in by calling this function. So now we have a base model data frame. And then we loop through all our comparison models. And we load them in. We merge them with the base model. We find the difference in reaction values. And we save that into the data frame. So now we have this nice dictionary here where we have all the data frames in, and they all have the information compared to the base model. We can then create a function for plotting them. We call that function plot and save, where we put in the data frame and we tell it where we want to save the output of this function, so the figure that comes out in the end. And then all of this here is pretty much just a repetition of what we did before. So let's try to run this code and see what happens. So now you can see that for every model, we get these plots out here. So we have a plot here that shows the absolute difference, so the difference in kilonewton between the models. And we also have one here that shows the relative difference between the models. And now we're just visualizing this here for one load case, but you could of course loop through all load cases in your project and all load combinations and just save this output into a folder. So now, rather than you decide now what plots you want to create, you create all of them. Maybe it's not you writing the report for this structure, but now you have helped the guy writing the report by generating all the plots that he could ever wish for. So now our script has automatically generated this folder here. So there's a folder for each model, and in here you have the two plots. You can make them a little bit bigger here. And now the benefit of this is that when you're writing your reports, normally you would go into Excel, you would create the plot you need, you would copy paste it into your report. And then if you later find out that actually it's a different plot you want, or maybe you want to include the plots for all different wind directions, for example, then you can just go into your folder of plots rather than having to go back in and run things in Excel again. This also makes it very easy if you're making slight changes to your model. Then rather than going through Excel and creating every single plot again, you just run your script and you have an updated folder with all your updated plots. So just with some basic Python knowledge, knowing the Python standard library, knowing some matplotlib, knowing some pandas, you can create some of the most amazing structural engineering tools. And now this here is just an example. Whatever key performance indicator that you have on your project, you can visualize like this. So rather than spending your time copy-pasting data around, you can spend your time doing actual engineering. And when you've learned these techniques here, not only is it faster to do, the outputs you will generate are also a lot better and they're reusable. And everything you've seen in this video is something that I also teach in the course Python for Structural Engineers. And you can find a link in the description. And either you can enroll now, or if enrollment is closed, you can sign up on the waiting list. Hope to see you there.